Hey everyone, we're going to continue with chapter 4. This is page 2 of the chapter 4 notes. We're still on 4.1. The topic is expected value, which I think is one of the more useful and important topics of probability. It's what's called average outcome, another word for it. And where you will see this is things like, well, for one, gambling or lotteries or poker, but also things like business, insurance companies. When insurance companies know the probabilities of things breaking or cars crashing, they can ensure in the long run that they will be making money if they know how to calculate expected value. So it has a formula. There's the formula for it. It's the same as the mean of a probability distribution, right? So we've seen that formula on the previous page. So let's look at an example. We've got the pick 3 lottery. Pay $1, and you get to pick any 3-digit number from 000 to 999. So notice there, it's important to note that there are 1,000 numbers to choose from, right? 1 to 999, and then also the 000. And then if your number is chosen, you win $500. Woohoo! Otherwise, you lose. Okay, let's find the expected value for this game. To do that, we're going to answer these questions. The first one is, how much do you win if your number is chosen? So notice you had to pay $1, you win 500. It doesn't say you to get that $1 back, so your total profit is only $4.99. Okay, and then what's the probability that you win? Okay, well, there's only one way to win because your number has to be chosen, and there are 1,000 possible numbers to be chosen. So that's one way to win out of 1,000 ways. Okay. What's your profit if your number is not chosen? Well, if it's not chosen, you don't have a profit at all. You have a loss, right? But you only lose $1. So we're going to use that -1 as representing that, right? You minus $1. Okay, what's the probability of losing? It's all those other ways, the 999 losing numbers out of 1,000 for you, right? So most of the time you're going to lose this game, right? Okay, so to figure out expected value, it helps to make this table and then we'll calculate it. So the x, the random variable x in this case, is dollar amounts. You're either going to win $4.99 or you're going to lose $1. That's all of the possible outcomes, right? Those are the only two things that are going to happen each week. Okay, and then we can do the associated probabilities. The probability of winning, we know, is that 1 out of 1,000, and the probability of losing, we calculated as that. Okay, now we're going to apply the formula, right? Remember the formula was this guy, so that means take the x times p of x, right? So we're going to multiply x times p of x together. So my calculator, I'm doing $4.99 times 1 over 1,000, or 1 divided by 1,000, and that's 0.499. Same with the other one is 999 divided by 1,000 times -1, negative 0.999. Last step is the summation. Add these two together, right? So my EV, whoa, what was that? I meant to draw an E. My EV equals 0.499 plus a negative 0.999. Right? Or basically 0.499 minus 0.999, same thing. And I'm getting negative 0.5. That is the expected value, negative 0.5. Now, what does that mean, right? Well, it's this parenthesis thing up here, right? It's how much you, in this case, lose per play on average over the long term, okay? It's lose because it's negative. So the unit of measurement for this matches the x. So this is dollar amounts. Your answer is dollar amounts. So this is $0.5 or 50 cents. And the negative represents lose. And then this is per game. So this is interpreted as, in the long run, you're going to lose 50 cents per game, right? So we're going to lose 50 cents per game on average in the long run. Okay. So this is a losing game for anybody that decides to play in the long run. It's a winning game for those who are putting it on. So if anybody is putting on this lottery, they're winning lots of money. They're winning 50 cents per player per time they play. It's going to earn a lot of money, raise a lot of money for the government here. Okay. How about another example? Roulette. Okay, roulette's a common game in a casino. If you've never seen roulette, you might want to Google it, but here's the information about it. You have a wheel with 38 numbered slots. 18 are red and 18 are black, and then there are 2 green numbers. And then the game pays even money for a red or black win. That just means if you bet $5 on red and then the number comes up red, the casino is going to pay you $5. So you get to keep your 5 that you put up, and they'll match it with another 5, right? If your number if it doesn't come up red, then they just take your $5. Okay, so let's do an example here. Let's just assume we bet $5 on black. What is the expected value if we do this in the long term, right? We keep playing this, $5 on black. How much do you win if the marble lands on black? $5, right? What's the probability of winning? Okay, let's look back. There are 18 black numbers and there are 38 total numbers. So the probability of winning is 18 out of 38. I'm just going to leave it like that. No need to do decimals or reducing. What is your profit if the marble lands on red or green? Those are losing for you because you bet on black. There's 18 reds and there are 2 green for a total of 20 losing numbers. Oops, I jumped the gun here. That's probability. What is your profit if the marble falls on red or green? We just lose our $5, right? Sorry about that. So the profit is -5. The probability is what I was just talking about, the 20 out of 38. Now we can notice right off the bat, this is not a fair game for the player because the money is the same, right? Either you win 5 or lose 5, but the probability that you win is smaller than the probability that you lose. That's not fair. So the casino will be making money in the long run and you will be losing money in the long run. And notice it would be the same if you bet on red. You're like, oh, well, let's not bet on black, let's bet on red. And it would be all the same if you bet on red, okay? So there's no decision you can make here for you to have a positive expected value. No matter what your decision is, you will have a negative expected value, and we'll see exactly and precisely what that negative expected value is by doing this table. So we have win 5 or lose 5. We have 18 out of 38 here, and we have 20 out of 38 here. And now I'm going to do a little math for that next block. I'm going to multiply 5 times 18 divided by 38. Right, 5 times 18 divided by 38, it's about 2.368. Let's go with that. 2.368. Bottom one, I'm doing 5 times 20 divided by 38. And that's 2.632, but it's negative. So negative 2.632. Okay, that's multiplying my x times my p of x. And finally, to get the expected value, I'm going to add those together, 2.368 plus a negative 2.632. Or essentially, it's just a subtraction problem, 2.368 minus 2.632. And I'm getting about negative 0.26. So let's just round that to negative 0.26 because these are dollar amounts. That's just the nearest cent. There's your expected value. It's negative, means you're losing in the long run. If you're the player, if you're the casino, that's a positive expected value. So this is good for the casino, bad for the player. And you're losing 26 cents per game in the long run. right? Which doesn't seem like a lot, but if you play this game a lot, that builds up over the long term. Okay, so that's expected value, a useful tool for sure. If you have any questions on it, let me know. I think there's just one example in the homework. I think it is roulette that you'll have to work through. So give it a go. If you have questions on it, let me know. Okay, next up will be 4.2. Talk to you later.